Hello, 7th graders. Welcome to 3.6.1, Introducing Graphs of Proportional Relationships. Here are the standards we're going to be working on. Our learning targets for this lesson are: I can build a proportional graph from a table, I can identify components of a proportional graph, and I can identify K, that constant proportionality on a graph. Here we have a table, which I hope is looking pretty familiar at this point. And we are looking at a situation where we have some t-shirts on sale and the shirts cost $8 each. We are being asked what the X represents and what the Y represents. I want you to pause this and think about it. So for this situation, our independent variable, or X, is going to be the number of shirts we've purchased, and our dependent variable, or Y, is going to be the amount of money we have spent. So go ahead and add that to the table on your notes. Next, we are being asked, is there a proportional relationship between X and Y? And in this situation, there is. We know that K is going to be our Y values divided by our X values, and that if that K is the same for every single ratio in our table, that we have a proportional relationship. And it's true here for all of these ratios. If you take your Y and you divide it by your X, you end up with the same value of K equals 8. So now that we're getting familiar with our tables, we're going to extend that knowledge to now see how can we start using tables to make proportional graphs. If you have a table, the easiest thing to do is that you know that all coordinate pairs are one X and one corresponding Y, and that's really all a table is. So we could fill this first one in to be the coordinate point 1, 8. And we could do the same for all of those, 2, 16, and so on and so on and so on. And then once you have all those coordinate pairs, you can go ahead and just enter them onto your graph. So here I've gone ahead and graphed all of those coordinate points we came up with on that last table. And we are being asked some questions about this new graph. The first thing we are being asked is, could we buy 0 shirts or 7 shirts or 10 shirts or half a shirt? And the answer to that is that while 0, 7, and 10 would make sense, this whole idea of a half a shirt wouldn't quite make sense on this graph. You can't really purchase half a shirt. But suppose instead of price per shirt, this graph is displaying the cost of cherries that are $8 per pound. How could we change our graph? So now that we're looking at cherries per pound, we can buy half a pound of cherries or 1.5 pounds of cherries, and so on and so on. So one thing we could do here is we could go ahead and make a line through all of our data points to show that really we don't have to just have whole pounds of cherries. We can buy any quantity of cherries we darn well please. And that's what that line would represent. The next thing we are being asked is, where can you see K, the constant of proportionality, on this graph? So if you remember, our K that we came up with on our table is 8. And I'd like you to notice that right here, let me get out my pen. Right here, where X equals 1, we have the point 1, 8, where Y equals 8. And that is actually going to represent your constant of proportionality on any proportional graph. So when X equals 1, Y is going to equal K at that point. All proportional graphs, no matter what story they tell, are going to have the same 3 characteristics in order for them to indeed be proportional. The first characteristic, if you're trying to decide if a graph is or is not proportional, is that that graph must pass through the origin, which is the point 0, 0, or when X equals 0 and Y equals 0. It is this point right here. If the graph is proportional, it will pass through the origin. Second, if the graph is proportional, it will be linear, meaning it will make a straight line. No curves, only a straight line. So you can see right here, this is a straight line, and therefore that is one piece of it being proportional. The third interesting takeaway from all proportional graphs is that k, that constant in proportionality, is going to be the point where x equals 1, and that's what we just saw on that previous slide. So in this case, where our x is 1, we follow that up and see that that is where our y is 8. And so that point where x is 1, that y value is 1 comma k. K is where the y is. Next, we're going to look at some stories talking about the amount of trash that seagulls can eat, and boy, can they eat trash. So here's the proportional graph showing us relationship between the number of seagulls on a beach and the pounds of trash they can eat each week. The first thing we are being asked is, what does this one given point, 4, 10, represent? Go ahead and pause, take a look at the graph, and see what you can come up with. So since x is going to represent the number of seagulls we have and y the pounds of trash they eat, if we have a point 4, 10, that means that 4 seagulls can eat 10 pounds of trash. Next, we're being asked, how can we use this graph to calculate k, the constant of proportionality? Now remember, we saw in the previous that that point is going to be where x is 1. We can follow that up, and right here we can see that we have a point that is not at an exact intersection of our grid. You never want to estimate when you are looking at graphs, you always want to calculate. However, we can use this point, 410, and our formula, k equals y divided by x, to do that calculation. Pause and see what you come up with. If k equals y divided by x, then that means our k is going to be 10 divided by 4. So k is going to equal 2.5, which means that this point right here is 1, 2.5. And on graphs like this, or the one where we're selling t-shirts, it's not always possible to interpret the meaning of every point on a solid line. For this situation, only whole numbers of seagulls would make sense, because we don't really care how much trash half a seagull can eat. But it can still be useful to draw a line, even if we can't interpret every point, because it helps us see rate of change. It helps us see how things are growing, and it can help us make some estimations about where other important data pieces are going to lie. So the 3 big takeaways from today. 1, we can interpret points on a proportional graph and know what they mean. We know that this point right here means that 4 seagulls can eat 10 pounds of trash. 2, we know that all proportional graphs share the same 3 characteristics. They go through the origin, they are linear, and that point 1, y is where you can find your k. Which brings us to that third, is that we can use any x-y coordinate pair to calculate k using k equals y divided by x formula. All right, go ahead and grab those journal problems, and good luck, y'all.